Welcome to this video on current, potential difference, and resistance. This GCSE Physics revision session will help you master these three fundamental quantities to confidently solve any circuit calculation on your exam. In this video, we will cover four key areas: defining electric current, understanding potential difference, exploring resistance, and finishing with essential tips for your upcoming exams. First, what is electric current? It is the flow of electric charge around a circuit. In metal wires, this charge is carried by electrons drifting from the negative to the positive terminal of a cell. The faster the charge flows, the larger the current. Current is measured in amperes, or amps for short, using an ammeter. 1 ampere equals 1 coulomb of charge per second. Ammeters must be connected in series with a component, meaning they sit within the same loop so all current flows through them. To summarize, current is simply the flow of charge. In metals, electrons are the primary charge carriers. Remember, an increase in the number of charges flowing results in a larger measured current. Next, let's look at potential difference, also called voltage. It represents the energy transferred per unit of charge as it moves between 2 points. You can think of it as the electrical push required to drive charges through a circuit. When studying potential difference, remember that it is measured in volts. A 9-volt battery, for example, transfers 9 joules of energy for every coulomb of charge passing through it. Higher voltage simply means more work is done on each electron. To measure potential difference, use a voltmeter. Unlike an ammeter, a voltmeter must be connected in parallel across the component. Because it has very high resistance, it ensures that the circuit's operation isn't disturbed by the measurement process. Here's a quick summary for your notes. Potential difference is measured in volts with a voltmeter connected in parallel. It is the vital push that keeps electrons in motion. Now let's discuss resistance. Resistance is the property of a material or component that opposes the flow of electric current. Understanding resistance is fundamental to predicting how any given circuit will behave. Resistance acts like friction for electrons. It limits current, converts electrical energy into other forms like heat or light, and is measured in ohms. A resistance of 1 ohm allows 1 amp of current when 1 volt is applied. Remember this inverse relationship. For a fixed potential difference, higher resistance results in lower current. Specifically, doubling the resistance will halve the current flowing through a component. Different components have unique resistance properties. Lamps change resistance as they heat up, while LDRs and thermistors change their resistance based on light intensity and temperature, respectively. Fixed resistors, however, maintain a relatively constant value. Finally, the core of circuit calculations is Ohm's law. Potential difference equals current multiplied by resistance. If you know any two of these values, you can calculate the third. Memorizing this formula is essential for your exam. Let's walk through an example. If a resistor has 20 ohms of resistance and 12 volts is applied, the current is 12 divided by 20, which equals 0.6 amps. Always include the unit in your final answer. Moving on to our third chapter, electric circuits. Remember, current can only flow through a complete, unbroken loop. Building and controlling these paths is a core skill for both exams and practical applications. A circuit must be a continuous loop for current to flow. Any gap, like a broken wire or open switch, stops the current completely. A torch is a simple example. Pushing the button completes the loop to light the bulb. Switches act as the gatekeepers of a circuit. When open, there is a gap, and current cannot flow. When closed, the switch creates a complete path, allowing the current to pass through and power your device. Cells provide the potential difference, or voltage, needed to push electrons around the circuit. Connecting multiple cells creates a battery. Higher total voltage transfers more energy, driving a larger current for a fixed resistance. It is essential to distinguish between series and parallel circuits. In a series circuit, there is one single path. In parallel, the current divides into multiple branches. Be ready to identify these types in your exams. In series circuits, current is the same everywhere. However, the total voltage is shared across components, and if one part fails, the entire circuit stops working. These are common characteristics you'll see in diagrams. Parallel circuits operate differently. Current splits at each junction, and the voltage remains the same across every branch. If one branch is disconnected, the others continue to function independently. Placement matters for measurement. Always place an ammeter in series to measure total current. Conversely, a voltmeter must be placed in parallel across a component. Misplacing these is a common way to lose marks. You must be fluent in reading standard circuit symbols. From cells and resistors to lamps and switches, memorizing these icons ensures you can interpret complex circuit diagrams accurately during your test. Linking current, voltage, and resistance is the fourth chapter of our study. The formula V equals I times R is your primary tool for solving these physics problems and will be your best asset on the exam. To use the V equals I times R formula easily, try the triangle method. Cover the variable you need to find, and the remaining values show you whether to multiply or divide. It's a reliable visual trick. Keep these relationships in mind. Increasing voltage increases current. Increasing resistance decreases current. If current increases for a fixed resistance, it implies the voltage applied must have also increased. Components can be ohmic or non-ohmic. Ohmic conductors show a linear, proportional relationship between voltage and current. Non-ohmic components, like filament bulbs or diodes, have resistance that changes, causing curved graphs. Interpreting IV graphs is a key exam task. You must be able to describe the curve or line shape and link it to the resistance of the component. Practice sketching these to build your confidence. For your final exam technique, always follow 3 steps. State the graph's shape, link that shape to the resistance, and use provided numerical values if possible. Specificity helps secure those extra marks. Resistance is essential in our daily lives, influencing how every electrical device functions. From the heat generated in a kettle to the glow of a light bulb, resistance is the mechanism that converts electrical energy into useful forms. Several factors affect resistance. Longer wires increase resistance because electrons face more collisions. Thicker wires decrease it by providing more space for flow. Finally, the material itself matters, as different substances have unique resistivities. Let's summarize the 3 core quantities. Current is the flow of charge measured in amps. Potential difference, or voltage, is the energy per unit charge measured in volts. Resistance is the opposition to flow, measured in ohms. Use this checklist to prepare for your exam. Can you define these terms? Use the V equals IR formula and interpret circuit diagrams or IV graphs? If you can confidently check these off, you are ready. Here are 4 top exam tips. Always place ammeters in series and voltmeters in parallel. Show you're working clearly for every calculation, and double-check how you rearrange your formulas. These small details ensure you get every possible mark. Common mistakes include confusing current with voltage, placing instruments incorrectly, forgetting your final units, or poor algebraic rearrangement. Avoid these traps by memorizing your rules and practicing your steps thoroughly. Test your knowledge with these practice questions. Calculate the potential difference for a given current and resistance. Find the resistance from voltage and current, and explain the roles of meters and resistance in circuits. Check your answers here. Ensure you follow the correct V equals IR steps and understand why instrument placement is crucial for maintaining accurate circuit readings. Consistent practice is the best way to master these concepts. This table lists key vocabulary, definitions, and units. Use it to create your own revision cards. Memorizing these precise definitions will help you write clear, high-scoring answers in your upcoming physics examination. You have the tools you need to succeed. Remember the formulas, respect the rules for circuit meters, and always include your units. You've got this. Good luck with your revision and your final physics assessment.